Now we switch over to inequalities, and we're going to solve these algebraically, and we're going to use a sign chart again. We need to treat the zeros of the function only slightly different than the vertical asymptotes of the function or the undefined points of the function. Okay, so but this whole sign chart idea is the same. Okay, so oh, you know what? I'm going to move this down like I did before because I want to have a little space for my sign chart before I start. So I'm going to move this down even a little further, a little over this way. Okay, because my sign chart really answers all four parts, right? Okay, so first of all, where does f of x equal 0, right? And that is the x-intercepts. Right? So x is equal to, if you recall, we've already studied rational functions. Remember, that was a lot to learn, but the x-intercepts are the numerator of the function. Okay, so the numerator is what gives you the zeros or the x-intercepts. So that would be -2 and +6. Okay, so that's the answer to part A. But for our sign chart, we also need to find out where is the function undefined. Okay, undefined means where it makes the denominator equal to 0. And I said before that would be a vertical asymptote, but it also could be a hole, a removable discontinuity, right? So the function is undefined at x is equal to -2 and 3. Okay, and now I paused for just a second there because look, I had actually said the x-intercept was -2, but that it also makes the function undefined at -2. It can't be both, okay? So really when we would do this function, the -2 would get eliminated. It is not an x-intercept, okay? I'm glad I did that because, you might not notice that, and then if you have it in both places, it doesn't make sense. So it is an undefined point because it is in the denominator. If we put in -2 to the original function, we would get 0 over 0. That is undefined, okay? So the only x-intercept is 6, and then the two undefined points are -2 and +3. Okay, so we're going to make our sign chart from those values. Okay, so we have -2, 3, and 6. Those points, undefined or zeros, are the only places where the graph can change from being positive to being negative. Okay, so you can see on this little graph, yes, even memes can be rational functions, that the asymptote is where it's changing from positive to negative. Okay, not just zeros. So let's put in our test points. -3. Let's use 0, let's use 4, and let's use 10. Okay, so just putting in some numbers there. Remember to write those in a different place than you write the zeros. Okay, so let's put those in. So if I put in -3, so I actually can put it into the simplified function. So I'm going to simplify this function. It'll just, you might be wondering that, and it will save you time. So if you cross the x plus 2's out, if you divide them out, you get x minus 6 over x minus 3. And we can just put it in there to save a little time. So that would be -3 minus 6 on the top and -3 minus 3 on the bottom. So that's a negative over a negative. A negative divided by a negative is going to equal a positive. Okay, so this area of the graph is positive. See, I'm writing POS because I think if I write a negative sign or a positive sign, it'll get lost because I'm squished. All right, so put the 0 in. Put 0 minus 6 over 0 minus 3. So that would be negative. That's a negative over a negative. A negative divided by a negative is another positive. Okay, so this is still positive. Now I'm going to put in 4. So that would be 4 minus 6 divided by 4 minus 3. Okay, so 4 minus 6 is negative, but 4 minus 3 is positive. A negative divided by a positive is a negative because it's just one negative sign. So this is a negative. And then I'm going to put in 10. And let's see, that's 10 minus 6 over 10 minus 3. Well, that is a positive divided by a positive, so that's a positive number. So this area is positive. Okay, so in other words, I have a positive here, a negative, and a positive. What I like to do on these before I go and answer the questions is I like to say, okay, this 6 is a 0, so I can include this point if it's like greater than or equal to 0 or less than or equal to 0. But then these two are wholes or asymptotes, and I need to use parentheses on them every time. Okay, so these two are always going to be parentheses because they're undefined points, so I can't include them. Okay, so it says first, where is f of x less than 0? So remember, that's just where our negatives are. So we only have one of those, and that would be parenthesis 3 to 6 parenthesis. Okay. If we go right below that to part D, that's what I would probably do next. Less than or equal to, okay, we're still looking at that same interval, 3 to 6, okay. The 3 is that parenthesis because it was an undefined point, and the 6 is a bracket because it's a 0, okay. Then we do where is f of x greater than 0, and that, of course, is the positives. So it looks like we're going to have 3 intervals there. So that's negative infinity to negative 2, parenthesis, negative 2 to 3, parenthesis, and parenthesis 6 to infinity. Okay. And then here for f of x greater than or equal to 0, we want the positives and the zeros. Okay. So the positives and the zeros. That does not change our first interval because that wasn't a 0. And it doesn't change our second interval, negative 2 to 3. But our third interval would be bracket 6 to infinity. So I hope that makes sense to you, and I hope the method helps you to get these right and to be accurate. I think that my favorite part is how the sign chart translates directly to the interval notation for the answers. I think it's helpful.